Okay, today we will discuss about new chapter, that is the inverse trigonometric function. Okay. Okay, is it clear? And we know that the trigonometric functions generally are sine terms, cos terms, tan terms, okay. These are our trigonometric terms. Okay, now we have to discuss about the inverse trigonometric function. Before that, we have to clear about the what is the inverse of any function. Okay. Okay, first we have to know about the inverse of a function and what are the necessary conditions in which the inverse of a function exists. Okay, we have to clear about all the cases where inverses exist or not. If we have any two sets, if it is a set A contain the elements, okay, that is the three elements, and now the set B contains the three elements such as A, P and C. Okay, now we have a function which is defined from set A to set B. Okay, it is a function f, or we can say it is a relation by which the element of set A connected to the element of set B. Okay, here the element 1 is connected to A, okay, 1 is connected to A, 2 is connected to B, and the 3 is connected to the C. Okay, that is the element of B. Okay, now we have defined our function f. Okay, the function is defined from set A to set B by which the element of set A connected to the different element of set B. Okay, here it is a 1 1, okay, here it is a 1 1 on 2 mapping, and according to the definition of 1 1 mapping, the each and every different element of set A connected to the different element of set B. Okay, there is no element left in the set of A, and the element of set A have a unique image in the set of B. Okay, and according to the definition of onto function, the each and every element of set B connected to the element of set A. Okay, there is no element left in the set of B. Okay, so where the given relationship or given function satisfy the conditions of 1 1 function and onto function, so where we can say it is a type of 1 1 onto mapping, or we can say it is a bijective way. Okay. We have to discuss about the bijective mapping because of inverse exists only for bijective mappings. Okay. Here we have a necessary condition of okay, here we have a necessary condition, that is the inverse exists only for the bijective mapping. Okay, if we have the 1 on 2 functions, then we can directly finding out the inverse of that the function. Okay, here the function must be 1 on 2. Okay, if we are interested to find out the inverse of any function, then the function must be 1 on 2 function. Okay, that's why we are discussing about the bijective mapping. Okay, or 1 on 2 mapping. So here in the given function f, which is defined from set A to set B, a reverse function we can also define, that is the g. Okay, is it clear? And another function g relates the element of set B to the element of set A. Okay, here we can define our another function g okay, which relates the element of set B, the element of set B to the element of set A. Okay, okay, is it clear? If we have the any another function g which is defined from set B to set A, in which the each and every element of set B connected to the different element of set A. Okay, here we can say directly the function g which is defined from B to A, it is the inverse of the function f. Okay, here we have the function g and here we have the another function f. So on the basis of bijective mapping, we can say okay, it is the inverse of the function f. Okay, which is represented as g is defined as from B to A, or we can say f inverse is such as okay. Is it clear? We have simple definition of 1 on 2 function, that one element connected to a unique and different element Okay, so here in the given case, we can define a reverse function or inverse function g such as which relates the element of set B, that is A, B and C, and it relates the element of set B to the element of set A, that is 1, 2 and 3. Okay, is it clear? Now okay, if any function f is such as which is defined from set A to set B, so here the set A contains the element 1, 2, 3, that is the domain. Okay, so here the set A is the domain of the function f and the set B is the range of the function f. Okay, the set A contains the element 1, 2, 3, which are the domain of the given function f. Okay, that is the domain of the function f. And now here the range of the given function f will be okay, is it clear? The function f have the domain 1, 2, 3 and the function f have the range a, b, c. Okay, that is the elements of the set B. Okay, now move on to the function g, which is the inverse of the function f. Here the function f inverse is defined from B to A, so the set P must be the domain of the given function f inverse. Okay, and it is the range of the given function f inverse. Okay, is it clear? Now we have to specify our domain of the function f inverse and the range of the given function f inverse. Okay, okay, here we have the any function f which have the domain 1, 2, 3 and the range contain the element a, b and c. Okay, now move on to the another function g, which is the inverse of the function f. Okay, contain the element in its domain are 1, 2, 3 and the range of the given function f inverse will be a, b and c. Okay, so on the basis of these two, okay, we can define the domain of the f inverse, which is the A, B and C, okay, because we know that the f inverse is defined from B to A, where the set P is the domain of the given function f inverse. So here we are having the element A, B and C, which are the domain of the f inverse, okay. But now in the given case, in this case, A, B, C is range of the given function f, okay. Is it clear? And now move on to the next one. The range of the given function f inverse, here the range of the given function f inverse will be 1, 2 and 3, okay, because the element of set B connected to the element of set A, okay. So the range corresponding to the function f inverse, we are getting 1, 2 and 3, okay. Is it clear? And 1, 2, 3 elements are the domain of the function f, okay. The set A contains the element 1, 2 and 3, which is the domain of the given function f, okay. Is it clear? So in the inverse of a function, the domain changes into the range of the given function and the range converted into the domain, okay. Is it clear? Okay, let's take any random example. If any function fx is defined from r to minus 3, 4, where r stands for any real value, okay, and the function fx have the domain r, which is the any real value, and the range of the given function is minus close bracket minus 3 to 4, okay. It is the interval in which the value of the fx we are obtaining, okay. Now move on to the inverse of that function, that is defined by gx is equal to f inverse x, which is the inverse of the function fx. Now here the domain converted into the range of the function f inverse x, and the range is converted into the domain, okay. So here the domain of the function f inverse x will be the range of the function fx, okay, because the f inverse of any function relates the range of the given function fx to the domain, okay. Here we have a reverse relationship that is defined from range to domain, and here we are having the domain of the given function will be minus 3, 4 to r, okay. Is it clear? Okay, here say we can say directly the domain and the range interchange with each other in case of inverse function. Okay, if we have any function f(x) which is defined from r to minus 3 comma 4, now the domain of the given function f inverse x will be the minus 3 comma 4, and which will be defined from minus 3 comma 4 to r. Okay, is it clear? It is very important to understand what is going on in the inverse function. Okay. Okay, all trigonometric functions such as sin theta, cos theta, tan theta, cosec theta, sec theta, and the cot theta, we know that these all trigonometric functions are periodic functions, and the inverse of a periodic function does not exist. So now we have to calculate the inverse trigonometrics. How we will define our inverse trigonometric function with the help of the definition of inverse of any function, whereas we know that the inverse of the periodic functions do not exist, but if Okay, we know that these are the periodic functions, and the inverse of the periodic function does not exist because of the periodic function doesn't satisfy the condition of the 1 1 or 2 functions. Okay, that's why we are not taking the inverse of the periodic functions. Okay, but when we are doing the restriction and the constraint on the domain and the codomain, then we can define the inverse of the trigonometric function. Because of on constraint, on restriction on their domain and the codomain, we can convert our trigonometric function, our periodic function, into the a bijective functions. Okay, okay, is it clear? Inverse of trigonometric function is defined in their specific or constrained domain where the function is bijective and fulfill the necessary condition of 1 1 on 2 functions. Okay, is it clear? So here we can say the inverse trigonometric functions. In the inverse trigonometric function, we can define the inverse of the trigonometric terms such as sine, cos, tan, cosec, sec, and cot terms. Okay, by simply specifying their domain and the codomain. Okay, is it clear? Now move on to the first one, that is the sine inverse x. Okay, we have the first inverse trigonometric function, that is the sine inverse x. Now we have to discuss all the property of the sine inverse x, what is the domain and the range of the given function sine inverse x, and how it behaves. Okay, Before that, we have to clear about the term sin x, okay? Sin x. We know about the term sin x which have the domain okay. The sine term have the domain any real value r, but it always gives the value in between -1 to 1. Okay, is it clear? Now we have to define our term, that is the sine inverse x. Okay, it is the inverse function of the sine x. So here the domain converted into the range of the given function and the range converted into the domain of the function. Okay, so here we are defining our function, that is the sine inverse x will have the domain is equal to -1 to 1, the interval, the closed interval of -1 to 1. Okay, and now we have to specify or constrain range corresponding to the term sine inverse x. Okay, if we are writing in case of minus close interval of -π/2 to π/2, here we are writing the case of r, then we can now define our inverse of the term sin x. Okay, so we have to specify or constraint or restriction on the term, on the range of the given function sin inverse x. Okay, in the given interval, the function sin inverse x, which is defined from the closed interval -1 to 1 to -π/2 to π/2, where it is the sin inverse x is 1, 1 on two functions. That's why we are writing our terms. The range of the given function is -π/2 to π/2, and we are having a closed interval on both the values corresponding to -π/2 and π/2. Okay, is it clear? Now we have to plot the term sin inverse x Okay, here we have the graphical representation of the term sin x, okay, which have the domain minus pi by 2 to pi by 2, okay. We are simple taking an interval, a closed interval between minus pi by 2 to pi by 2. So here we are having the interval which is minus pi by 2 to pi by 2, okay. And it is a x-axis and it is a y-axis. Now we are simply plotting our two values minus pi by 2 and pi by 2 on the x-axis, okay, for the term sin x. Now we have to move on to the range of the sin x, and the range of sin x is defined as closed interval minus 1 to 1, okay. So here we are having the range of the term sin x minus 1 to 1, okay. So we can plot the term sin x within the interval minus pi by 2 to pi by 2 to minus 1 to 1, okay. Here this is a graph of sin x, okay. Now we have to plot the graph of sin inverse x. First we have to clear about the domain of the sin inverse x and the range of the sin inverse x, okay. So here the domain of the term sin inverse x is minus 1 to 1. So here we are simply plotting our values minus 1 and 1 on the x-axis, okay, which is less than the value of pi by 2, because the value of pi is equal to 3.14 and the value of pi by 2 is equal to 1.57, okay. So the value of 1 will be less than pi by 2 and the value of minus 1 will also less than minus pi by 2. But here in the case of sin inverse x minus 1 comma 1 minus 1 to 1, it is the domain of the function sin inverse x, okay. We are simply putting the values of x which will be in between minus 1 to 1, okay. Now move on to the range of the sin inverse x, which is minus pi by 2 to pi by 2, okay. Now we have to plot our values of minus pi by 2 and pi by 2, which is generally greater than minus 1 and 1, okay. So here we are having the 2 points, okay. Here the first one is, and it is a second one. Now we have to simple connect these 2 points with the help of the nature of the sin inverse x, then we are getting a graphical representation of sin inverse x, okay. Is it clear? First we have to clear about the domain and the range of the inverse functions, and then we can easily write it as, which is defined minus 1 to 1, okay. That is the domain of the given function and the range is minus pi by 2 to pi by 2, okay. So here we are simply having the graphical representation of the sin inverse x and the sin x, okay. Is it clear? And with the help of graphical representation we can easily distinguish the nature of the two terms, which is first is sin inverse x and the second is sin x, okay. We can say easily the term sin inverse x is the inverse function of sin x and which have the mirror image corresponding to y is equals to x, okay. It is another property of inverse function. Okay, is it clear? The terms sin inverse x and the sin x, which are the inverse to each other, are symmetric about the line y is equal to x, okay. If we want to draw a line Okay, it is a line of y is equal to x. Okay, it is a line of y is equal to x, and we can say directly the sine inverse x and the sine x, which are the inverse to each other, are symmetric about the line sine y is equal to x. Okay, is it clear? Now move on to the next trigonometric function, that is the cos of x, and now we have to draw the cos inverse x. Okay. Okay, we know that the nature of the term cos of x, which have the domain R, where I stand for any real value. Okay. Okay. And R is the domain of the function cos of x, and -1 to 1, it is the range of the given function cos of x. Okay. It is the domain, it is the range of the cos term. Okay, is it clear? It's mean that the range is closed interval -1 to 1. It's mean that the possible values of phi will be in between -1 to 1. Okay, is it clear? So the range is of the term cos of x corresponding to any value of x, which is the any real value r. Okay, it always gives the value in between -1 to 1. Okay, is it clear? Now move on to the inverse of the term cos of x. Okay, so here if we are specify our interval, which is 0 to pi. Okay, is it clear? Now we can take the inverse of the term cos of x, which have the domain -1, 1 to 0, pi. Okay, is it clear? We are simply reverting our domain, that is the 0, pi of the cos x, into the range of the term cos inverse x, and the range of the term cos x will be converted into the domain of the term cos inverse x. Okay, is it clear? Now we have to plot our term cos of x and cos inverse x. Okay. Okay, is it clear? We have a graphical representation of the term cos inverse x by simply representing our term it is a graph of cos of x. Okay, we have to simply taking a mirror image or symmetry y is equal to cos of x. Okay, is it clear? And we know that the value of -1, the value of pi by 2, which is equal to 1.57, and the range of the given function y is equals to cos inverse x is 0 to 2 pi minus 1 to 1. Okay, so the value of -1, 1 will be in between okay, is it clear? Okay, so here we are getting the value of cos inverse x, which is symmetric about the line y is equals to x for the function cos x will be like this. Okay, okay, is it clear? It is the value of 1 to -1 and 1. We are getting the possible values of x in the cos inverse x. Okay, and 0 pi is the range of the given function cos inverse x. Okay, is it clear? We have a very simple okay, is it clear? If it is a line of y is equal to x which passes the origin point, and here we are having the term y is equals to cos x, it is the graphical representation of the cos x will be 1 to -1, which is the range of the given function, and 0 pi will be the domain of the given function cos x. So here the possible values of x that we can put in the value of cos of x. So here 0 pi, which is the domain of the function cos of x, and -1 1 is the range of the given function cos of x. Okay, now we have to find out the graph of cos inverse x. Here -1 1 is the domain of the term cos inverse x. So here -1 1 is the domain, and 0 pi is the range of the cos inverse x. Okay, okay, it is a line of y is equals to x, and it is a graph of y equals to cos of x for the interval 0 to pi, and it is a graphical representation of y is equals to cos inverse x in the interval 1 to 1, okay, where the minus 1 comma 1 is the domain and the 0 comma pi is the range of the given function cos inverse x, okay. And the rest of the inverse trigonometric functions we will discuss in the next class, okay.